I understand that some of you are struggling right now with the ANOVA analysis, and I really do understand the frustration. We haven't done a lot of statistics this semester, really none, and I am asking you to use some statistics for this final lab report. So what I want to do is make sure you have things set up correctly. If you will take a look at my table, and this is some data that I'm using, you were not really encouraged to manipulate the temperature of your water, but this is the example I'm going to use, and you can add your data in to a table laid out the exact same way in Excel. What I want you to do is, for your columns, I want you to type the independent variable that you changed. This is your amount of sugar, your type of sugar, your amount of yeast. Put in the different variations that you used. Then, going down as your row headers, put your minute listings. If you did more than one rep, that is fantastic. I applaud you. I am very pleased with that. Go ahead and list this down below. Once you get your entire table set up, what you're going to do is click the Data button. Go to Data Analysis. If you're not sure how to get this tool available, please go back and check the other video. Click Data Analysis, ANOVA Single Factor, and hit OK. You're going to click this Input Range Guide. Select everything, including the names of those independent variables you listed, down through all of your data. Click the box again. Make sure you note that your data is grouped by columns and that you have labels in the first row. Leave alpha at 0.05 and then select an output range. Now I have already run the analysis, so I would have selected this box, and then when I click OK, the information I have here came up. There is a lot of information in this ANOVA, but the only thing I want you to worry about, is right down here we have this p-value. This is where I want you to focus your attention. Yes, you can look at the F value and the F critical value, but what we're really interested in is the p-value. It's the easiest one to focus on. Remember that we set our alpha at 0.05. All you have to do is compare your p-value to the alpha. If the p-value is less than alpha, this means that your results are significant and meaningful, and that you can reject the null statistical hypothesis. Really, what this p-value is telling you is there is only a 0.1% chance that the results you got were the result of random chance and are not a true difference in the temperature of water on the production of carbon dioxide. So in this case, the p-value is less than alpha. That means you can reject your null statistical hypothesis. Let's take a look over here at a slightly different example. Here I have some different data, and this is all fabricated just to help you see the possible results. I set it up the exact same way. Bubble counts here, the independent variable across the top. Make sure you have your ANOVA organized by column for this setup. I run the single factor. Take a look over here at our p-value. P is 0.08. Remember again, alpha equals 0.05. This means that our p-value is greater than 0.05. So now we are going to fail to reject our null statistical hypothesis. This means that the difference we see in these bubble counts could just be due to random chance. There's more than a 5% chance of that. There's an 8% chance that this was random chance. And that's really not acceptable for a scientific study. We want a 5% chance or less. That's what this alpha is referring to. I understand that some of you feel like when you look at your data that it is meaningful. I understand that. However, for your discussion, if alpha is less than your p-value, you are going to have to fail to reject your null statistical hypothesis, even if you think the data looks significant. What you can do is, after you fail to reject the null, in your discussion, when you get to the part where it asks how you can improve this research, and when you talk about your biological hypothesis, explain that the results appear to show a positive correlation or a negative correlation or something else that looks meaningful. And while the statistics of the ANOVA do not show that, you think further testing is necessary. Explain what you think would be found with this further testing and how this further testing should be conducted in a way that might give you better data. Things like increasing the number of replications or changing how you take the bubble count, and explain how you would take the bubble count are some options you could consider. I hope this has helped you a little bit with your data analysis. If you are still having problems, please feel free to send me an email. If you did not submit a draft on time to your group and then also submit it on time to the Dropbox, I will not be looking at full drafts, but I will answer questions about the ANOVA. So please let me know if you have any questions. And overall, the report's looking pretty good. Hang in there. You are getting closer and closer to the end of the class.